Good afternoon. Thank you for sticking around for the final session here. My name is Josh Eccles. For those who don't know me, I am VP Engineering here at LabKey, and I've been involved in a lot of different aspects of LabKey Server over the years. But one of the areas that I've kind of had my fingers in for a while on and off is quality control. And that is really a pretty broad category of things. Means a lot of different things in a lot of different contexts. And so what I've tried to do as part of organizing this is break it into kind of a basic workflow and steps along the way where QC might come into play. And I'm definitely very interested in hearing from folks here, kind of what aspects they might be familiar with already, what things they've used with success or with frustration, and what things we're missing. So please, I think of this really as less of a presentation and more of a kind of discussion. I happen to have the microphone and the slide deck, but otherwise, let's try and make this a little bit interactive, especially here toward the end of the day. So the basic sequence, I thought, is kind of taking data from whatever your source is, getting it into LabKey, doing some reporting analysis of it, explicitly tagging it with what its state is, whether it's been reviewed, whether it's been approved, whether it's been rejected, whether it needs to be rerun or something like that. And then finally sharing that with others. So that might be publishing it within LabKey in a different spot where maybe collaborators have access, where they don't have access to the initial spot where you imported. Maybe it's exporting it in a way that you could submit it to, say, the FDA or a publication or something along those lines. So just kind of take those step by step through that entire process. Probably spend the least time here on the import side. I think a lot of the other talks have touched on some of these capabilities, but there's a lot of different things you might want to do to either flag data as suspect or just outright reject it, so it doesn't make it into LabKey Server because the problems are so bad. One thing that we've really, I think, iterated on with a lot of groups is when to outright reject and when to be tolerant and import and maybe have a report that says, here are things that are potentially problematic, but it's better to capture that data instead of saying, nope, we're gatekeepers, we're keeping it out, and then people get frustrated and never import it. I think one good example that we've been bitten by many times over the years is we'll ask a group, if you, let's say you have a sample list, and those are linked back to a subject ID, whether that's a human participant in a clinical trial, whether that's animal ID from the Primate Center, whether it's just a cell culture ID. And we ask, do you always have that subject information in the database before you try and import that sample that came from that subject? And the answer is yes, except a couple times. And so from a developer standpoint, I can say always is a little more definitive than that. And so we've generally tended to be a little more tolerant, and that's why in things like lookups, they're not true foreign keys in the database, because that allows us to fill in the data after the fact and have it link up. But that's kind of one thing to be thinking about as you're putting these kinds of import checks into place. Will it be something that's potentially self-correcting like that, where we get the new import of subjects and everything matches up? Or is it, no, this is a bad value, it's never going to be right, keep it out of the database completely? Some of the ways to do that are field validators. So these are things when you're in the designer for your list or data set or assay, you can say, this is a numeric value, it should always be greater than 0, or it should always be less than 100. Or if it's a character value, that it should be exactly 6 characters long, or it should be just alpha, no numeric. And those are really just looked at on an individual field-by-field basis for each row that's being imported. We have other capabilities called transform scripts. These are specifically attached to assays. They run on the whole file that's being imported. all at once. So instead of row by row or value by value, they get passed the whole file to process. And they can both transform the data, and they can also just do validation. Back in years ago, we had both a transform script and a validation script, and now we just have the general transform script. You can have as many as you like. They run in sequence, and they can pass error messages back to say, nope, this value is missing, or this value is out of range, or the curve fit that I did in my R package has a poor correlation coefficient, so let's reject it outright. And these things are essentially run out of process, so it's something that LabKey Server will shell out to kind of on the command line, so it's well suited for things like R, Python, Java, other programming languages that you just put your script on the server, point your assay design at that script, and let it do its magic. Then we also have trigger scripts, which are a little more general purpose. The transform scripts really only work on assays. Trigger scripts work across many more data types. So lists, data sets, lots of just general tables. If you have an external schema where you're mounting another database table and you're wanting to import data into that, you can attach a trigger script. These are put in a module. They're written in JavaScript, and they run inside the server. And they run row by row. And so you get past the whole row of incoming data. You get to look at it. Again, you can transform that. You can say, oh, let me do a calculation on that and store that as a separate column. Or you can attach error messages and say, nope, this value is unacceptable for whatever reason. I guess who's done any of these approaches so far? Has anyone written kind of the code? Avital, very good. How'd it go for you? Perfect. Okay, so that's kind of getting the data in. So imagine it makes it past our gatekeeping process, and that it's in the database, and we want to say, what's going on with this? So there's a lot of different ways you might be trying to analyze and understand your data. And I've broken it into two different categories. So the first is what I'm calling domain-specific checks. So this is something that the report knows something about the data itself. It's not kind of a general purpose approach that we're trying to apply to any data that comes in. So these, because they're aware of the type of data, it needs to be implemented for that type of data. And so these are typically kind of packaged inside of a module, or it might be a custom report that you've written, like an R report or a SQL query that understands something about the data and what it's supposed to look like. And we also have these more kind of generalized approaches, which are some of the things that Jim from PNNL mentioned in his presentation yesterday on the biofuels, where you can have a more kind of statistical process control mindset. These are things that have really been refined kind of in the industrial manufacturing world, and then applied to the lab and the processes there. And so I'll talk more about the specific plot types in a minute. But really, these are designed for something that should be consistent. So you're running a QC sample, say the first run of the day on the instrument, or every 10th run, or some regular cadence that allows you to know that your experimental results can be trusted because your instrumentation is working well. So just one example of kind of these domain-specific contexts I took from our primate electronic health record integrations that we've done with many of the primate centers. And so this applies, of course, to any type of EHR data, regardless of the source of the sample. But there are, hematology, biochemistry, other panels, urinalysis, where there's a well-established normal range or high or low values. Typically, it's broken up by species and sex, age, and here's a case where we've got the set of reference ranges imported for, I can't remember, I think these are rhesus macaques. And then the variety of things that are being measured in that panel, everything that looks green, is normal. And so the clinicians, the vets and the vet techs that are, providing the animal care can very quickly look at this because we've wired up the knowledge that here's what it's supposed to be. Anything out of that range is something to potentially investigate. But on to kind of the more general purpose tools that are built in, and hopefully some of these are things that you might be able to apply to some of the data that you've gotten imported to LabKey already. Or maybe it's you haven't been importing your QC runs, you've only been importing your actual unknowns, your experimental samples, and maybe there's some value in capturing all of that data inside of your LabKey assays. So the Levi Jennings charts are really where we started in this kind of statistical process control adventure. So in the kind of industrial manufacturing world, these are it's called Schuhart process behavior charts. Really what you're trying to do is you've got a process that should be reliable. You know what its output is supposed to be. You're monitoring that output to see is it in range or has it gone out of control. And think of this as really the longitudinal tracking, right? You run a bunch of history on this so you know what your expected values are, you know what your normal variation is, because odds are, even if something's supposed to be pegged at, say, 1,000, whatever the output is that you're measuring, it's probably got a little noise to it, moving up and down. But there are a lot of different ways that you can identify these things, either having already gone out of range or maybe kind of predictors that this is going to become a real problem in your process. And the Levi Jennings chart, named for Levi Jennings, the people who applied all of those great ideas or stole them to apply them to the lab context, really kind of focuses on standard deviation and the mean as the key metrics that it's tracking for whatever it is that you're measuring. Who here has used Levi Jennings charts, whether it's in LabKey or any other tool before? Okay. So the kind of history of this in LabKey is, I forget exactly when we started, maybe 8 years ago, 10 years ago, working in the Luminex module. So Luminex, for those not familiar, it's a plate-based assay, multiplexed, kind of fluorescence intensity type measurement. And we worked with a lab that essentially was adapting a workflow that they had already been following for a long time. They had a lot of historical data where they were monitoring the normal ranges for their controls that were really part of every plate. They had a handful of control wells, and they were monitoring those to make sure they were in the expected range. And again, that allows them to trust that their experimentals or their unknowns are trustworthy. We then later kind of rolled that out into our flow cytometry module and targeted mass spec, and that's really kind of built out beyond Levi Jennings now into all these other cool additional types of reports that I'll get to in a moment. But then we said, hey, wait, we've done it 3 times now. Maybe we should do this in a way that we can actually just leverage and feed in almost any data type. There's always a little tension because in the specific context of, say, targeted mass spec, we know there are some very specific metrics that people want to track, retention time and peak area and mass accuracy and things like that. And so we want to have those pre-configured, but we also want to bring kind of the power of these analysis approaches to whatever data feed you might have coming into LabKey Server. And so we gave it maybe a little awkward name, and we can talk with Will and smooth it over a little bit, but QC Trend Report. And so this is a premium feature. But you'll see it kind of specially wired up for assay data. But it can be applied to really anything that's been imported into the LabKey database. And you can either specifically monitor kind of a raw value, something that's just in a column in a table. But more typically, you might write a really small SQL query on top of that underlying data because you want to filter out certain data. You say, I don't want to look at my unknowns, I only want to look at my controls for this monitoring purpose. Or I want to go ahead and aggregate. I've got 3 replicates. Let's go ahead and sum those, take the mean of those first, and then that's the result that I want to be plotting. And then we said, okay, let's go ahead and add more charts because who doesn't love more charts? So these are also part of the statistical process control kind of methodology. And what they allow you to do is focus in on different types of variation or process problems. So the Levi Jennings plot is really just showing kind of the absolute value of whatever metric you're tracking. And these other charts, and Levi Jennings says anything outside of 3 standard deviations plus or minus from that mean, that's kind of the de facto standard for what's considered out of control. You might want to dial that back a little bit yourself, depending on the variability you have, but that's kind of the default view. These other plots give us visibility into, say, a more general trend that we haven't reached 3 standard deviations, but we've got a gentle slope going up that's going to get into trouble, and kind of ways to flag that in a more systematic way than kind of squinting at your plot and saying, I don't know, does that look bad to you? So what we've done is integrated these. Basically what I recommend for folks is to first look at these Levi Jennings plots. That's kind of the good spot to get your process dialed in. And then start looking at these other results once that's pretty stable, because otherwise you're just going to be trying to deal with too much noise up front. And I think what I'd like to do is go ahead and look at a concrete example of this in a way that does not end my slideshow. And I'm going to go ahead and look at a server called Panorama Web, which is a public repository. It's got a lot of great example files for Panorama, which is our targeted mass spec module in particular. Pretty much all of these basic tools are going to be available in that QC trend report, the premium feature that you can feed whatever your data source into. But this is a convenient example because it's already public. You just browse there without an account and kind of see what it's all about. So you can see we've got a number of different QC examples here in our list. Really, in the mass spec world, these are called system suitability checks, that you're making sure your system is suitable for the experimental data that you're looking to feed into it. And what we see in this plot here, or the series of plots, is we're looking at retention time, basically when a particular molecule is showing up in our incoming data, incoming to the instrument. And we have a number of different peptides that are being monitored. And so one of the most important things when setting up any of these processes is to find something that really performs stably. You don't want something that's already just bouncing around a lot because, say you're right on the edge of detection of that thing. You want it to be a nice, stable thing that you're monitoring because you don't want to have a lot of false positives to chase down in terms of outliers here. And so we can see over time, we've got, this is data from 2013 through later in 2013 here on the x-axis. And we can see the values, at least this time period here, pretty stable, pretty level. And our plots here are showing us, it's probably easier to see on the right-hand side here. The mean is the line in the middle, the gray indicator. And then we've got plus and minus 1, 2, and 3 standard deviations from that with the red, blue, and green dashed lines. And these shaded areas here are what we call a guide set. It's kind of the training range that establishes the norm for whatever it is that we're measuring. And so that's what we're using to calculate that mean. And then going forward, this white period in the background, we're using those same values from our training set to evaluate are our values in or out of our expected range. And you can see that because we have kind of a pronounced shift in retention time, starting at about August 21st, what we've done is we've created a new guide set to say, nope, there's a new normal going forward. That's what you should expect instead of what used to be normal. And you can see these little X's up here too. And these are really important because they allow you to annotate what is going on in the lab at that time. So those familiar with mass spec might be familiar with the idea of swapping out the column, which is going to influence your retention time. And granted, this is kind of fictitious data, but that's exactly what I annotated here. And people can either do that when they actually make the change. They say, aha, I'm doing something that may impact the results I'm getting. Let me kind of write that down and make it available for others to do for reviewing the results. Or you can say, something went wrong here. What's going on in my data? You track it down in the lab. Maybe your instrument needs cleaning. Maybe you ran out of your sample or it's degraded. Once you understand what happened, you can go back and annotate so that when you see the same trend next time, you can say, aha, that looks a lot like that. What happened before? Okay, now I've short-circuited a lot of that research. So I can go ahead and turn on the other plot types if we want to be overwhelmed. The plots here on the projector. You can see that won't go into the full detail of exactly what each one is tracking, but like I said, these kind of give us insight into either increased variability, so maybe the mean is staying the same, but we've got a lot more bouncing around that. That's what some of these QSUM and moving range plots give us, or that we've got kind of a gentle trend going up that each one by itself is still within our 3 standard deviation range, but everything is shifting up, and that's probably something that we need to investigate, maybe recalibrate, et cetera. Any questions on this type of analysis? Yeah, Jim. Mm-hmm.
Is this chart available across LabKey in all instances?
Yeah. So I don't have that set up for demo here, but yes, that's the QC trend report that I mentioned. So that's a premium feature where you can, it's most easily attached to an assay. There'll be a menu option up on the top to create one, and essentially what you need to do is point it at whatever the value is that you want to be monitoring. Maybe that's exactly, a column, whether that's kind of a direct column in a table or some calculated or filtered value from a custom query. And so for a plate-based assay, maybe that's the fluorescent intensity of your control well or something like that. And then essentially what that does is it just is the incoming data feed, whereas in Panorama, it's kind of pre-configured because we know retention time and peak area are metrics of interest. Yes? So the annotations here, so I'll have to sign in to do that because I'm not allowed to do that just as an anonymous person. And if I remember my password for this particular server, I do. Look at that. Okay, and yeah, I guess it's worth mentioning that for Panorama, we have ways of kind of overlaying these series. So here, instead of a separate plot for each peptide, we see a separate series for each peptide. So there are lots of different ways to visualize this, and if you have things that you expect might move in unison or might kind of move independent of each other, a lot of these plots can be kind of good ways to look at that. But here in Panorama, there's the Annotations tab. And the annotations, I should say, are specific to Panorama. That's not something that we've added as a general QC reporting capability at this point. But what I can do is it's just kind of a standard LabKey grid. I can go ahead and insert a new row. Here in Panorama, we've got a handful of kind of classifications, types of things that might be resulting in the change. So I could say instrumentation change, and I could say tech recalibrated. And if that was today, I could say 10/4/19 and save that. So really, it's a pretty simple feed. This could, of course, be populated by any of the import mechanisms in ETL or anything like that if we have something that would be interesting to automatically annotate. But so far, these have been kind of more the manual. No, I physically did something to the instrument. It's out of the ordinary, and so it's something that folks have just typed in like this. And then now that I'm logged in, I can go ahead and I won't make it stick. But if I go back to kind of a separate plot for each peptide, the way that I kind of create one of these training ranges, like I say, create guide set, and I click and drag and say, that looks relatively stable, and I could click create. That would create a new gray shaded area, calculate the mean, standard deviation for that, and everything in that range, and going forward would use that as kind of the expected norm. Any other questions on any of these plot types? Has anyone gone beyond the Levi Jennings plots into moving range or Q-sum analysis? No? Well, I encourage you to give it a shot. Like I said, it's good to start with the Levi Jennings because that really helps you kind of get it dialed in and then move to the kind of more nuanced detection down the road. So guide sets talked a little bit about the interface in the more general QC trend report is a little different, where you can actually explicitly give it the values that you want to use for the mean and the standard deviation. This was really important for a lab that had a bunch of historical data in a different format. They didn't want to import all of that just to teach LabKey what the expected range was, and so they just took those calculations that they had done years ago and were using and enter those. And one of the nice things about the approach is that you can kind of segment data into different categories, so that you can essentially have a multiple series of plots. Just like in Panorama, we have a separate plot for each peptide. You could break it up by whatever type of analyte you're tracking, or different metric that you're looking at. Another way that you might be thinking about assessing QC is less on kind of the system suitability side, so less on is my process working, is my instrumentation working. It's how much can I trust that the wet lab practice, or that however I prep these samples is consistent. And so looking at variability across replicates, whether those are technical replicates, biological replicates, any other process, can be a very common way to assess the quality of your incoming data. So I think what I've seen most often is people looking at, say, the mean value or the percent coefficient of variation across a collection of replicates, whether that's 2, 3, 4, however many you're running in your particular case. For the most part, these are handled for now as kind of a custom query in LabKey or an R script or something like that that's calculating these values. Some of the assay types do have a built-in notion of this. So for Luminex, you can import either the raw well-level data or the already summarized, already aggregated by the instrument that's producing the file version. But LabKey, during the import process, will calculate these metrics across the replicates if it's the raw well-level data. Okay, so moving on to the next phase of the process, we've got our data in, we've got some way to assess it, and then now it's more about communicating the status and understanding, helping others understand how much curation's happened, if any. And the way that we have typically done this in LabKey is something called QC state. This used to be unique just to study data sets, but it's more recently moved to be applied to some other data types, which is great. The way this is set up is that we have an administrator sets up the potential states something could be in. And that's typically something like not reviewed, reviewed and approved, reviewed and rejected, and some other variants among those things. These could be either moved via some sort of automated process, where maybe you're batching up a lot of incoming data, and then you run a script or some other analysis that looks at it in aggregate and decides to promote it and tag it as being approved. More often, I think it's someone who's actually logging in, a statistician or someone else with expertise, and saying, yes, that looks good to me. In some cases, I've seen it be more of like a PI kind of reviewing a lab tech's work on their team, and then saying, yep, I'm signing off on this data. You can configure the default state for incoming data. So anything new that's inserted, whether that's someone at a keyboard or via an API or ETL, what QC state does that land in if someone's not explicitly telling you up front? And then you're able to, through the user interface, if you've got edit permission on that, go ahead and promote or reject data to other QC states. Who here has worked with QC states, whether it's data sets or any other way in LabKey? So one of the areas that we've rolled this out into, graduating outside of just data sets, is assay QC. So in data set land, in studies, the QC state is really just kind of a tagging metadata approach. It doesn't control permission for who can see it. It might be excluded by default by a filter, but it's still available to someone to get to. In assay, we had some requirements from other groups to make it completely hidden from users if they don't have a certain permission, if it hasn't been explicitly approved already. And so in assay land, unlike data sets where the QC tracking is at the individual data set row level, assays it's at the run level. It uses the same collection of QC states as data sets. So again, usually kind of unreviewed, approved, rejected, or your other variation that you might have a kind of category of rejection. It looks like there is a problem with the sample, looks like there's a problem with the analysis. You could distinguish those. And then in assay, this QC analyst role, it shows up if you have the premium module, and it actually prevents you from seeing it if you're not in that QC analyst role and it hasn't been approved yet. And also if a run has not been approved yet, it prevents it from being able to be copied into a study data set. It's kind of a gating step that someone must explicitly promote it before it can even go out to that shared spot in the study. It's worth noting that one of the key scenarios that drove this was some of the assay integration with biologics. And so it was great to be able to fold this back into the standard LabKey server assay views as well. All right, kind of the last stage in the workflow is sharing your awesome results with the world. And so there's a number of different ways you might be thinking about the appropriate ways to do that, and also kind of retain the data in the state where it was ultimately approved and signed off on. And so query snapshots are a way to take the current state of the data and snapshot it into a new table where it lives. And you can set it to auto refresh, but I think from kind of this workflow's perspective, you'd want it to remain static. So you're saying, I've got this, it looks good to me. I don't want any new data that's coming in to automatically show up in these other views, so I want to freeze that and put it off to the side. Maybe you want to manually refresh that, say, at the end of next month when you're ready to promote the next batch. But it's a way to kind of have that snapshot frozen so it doesn't pick up anything new that you don't want to be there. And then maybe kind of a more fully packaged approach that's pretty similar is study publish, where you might have a full LabKey study and you want to snapshot the entire thing instead of just one data set within it. So you can go ahead and either copy the whole study or just a particular slice of it. Maybe you say, I only want data for these participants. I only want data in these 4 data sets, even though I've got 10 total. And go ahead and create a separate copy of that. It's another full LabKey study. Again, it can either be automatically refreshed or something that you manually promote again in the future if you want to update it. And that new copy can have totally separate permissions from the source data because it's a whole separate folder, a whole separate study within LabKey Server. Yes, those who have been at previous LabKey conferences or looked at some of the Zika portal work, where Dave O'Connor from the University of Wisconsin-Madison, basically they have what they call their master study, where they have all of their Zika data for all their animals on study in one centralized place. Then they copy, using the study publish process, subsets of that data out for Project A, for Project B, for Project C. They don't have general public access for that central master copy, but all these other copies they set to be fully public, and that's a way that they kind of control and subset that data, and also make sure we're comfortable with this version of the data. They're doing it pretty frequently. This is kind of a once a week or once a day snapshotting process, but it gives them kind of a little more control, do their work, make sure it looks good, and then go ahead and promote it to that public spot. And then kind of a final category of this is around electronic signatures. So this is another premium feature, something we introduced last year, designed to comply with Part 11 from the FDA. And really it's kind of a slightly different approach to snapshotting the data. Instead of copying it into a separate database table behind the scenes, we essentially do an export like you would manually in the user interface to Excel or to text, and stash that away as a read-only copy in the database. That gets attached to an audit trail in terms of both creating it as well as downloading it or otherwise viewing it, and requires a more explicit sign-off from the person doing it, including per Part 11 requirements, the reason, what is the expected state of this data, and why were you doing this? Is it part of a submission, or is there some other reason that you want this snapshot saved away and electronically signed? Yes, that's the end of my overview. I guess happy to take any questions on that, or folks just have other aspects of QC that they've encountered in or outside of LabKey Server they think would be useful to discuss with the group. Yeah, Will.
The QC plots, if you want to service them as something besides an assay, probably as well, like kind of a hard table.
Sure. So that basically the key difference, or the key kind of extra that happens for assays, is just that it gets attached to an assay design and attached to the navigation UI on the top. When you create a QC trend report, basically all you do is you point it out any query, any table in the LabKey schema browser. And so you just need to either do the standard navigation to the reports views, or put a link directly to it in a wiki or something like that. It's more how you get to it as opposed to how you create it that's different. Yeah.
Is there an intent to do like a row-based signature? Because right now in Engine, it has your user profile name attached. But if I personally view the change, it says view made the change. Is there any way to enforce things that actually not made the change?
Well, so we do, like I said, kind of capture the user based on who is being impersonated for those changes, but we have additional audit records to say, yes, but someone was actually doing an impersonation at the time. Granted, they're two kind of different audit logs. For the signature process, I don't think we've really had much demand for kind of that much finer grained level. I believe that you actually can use the checkbox selectors to do a signature on the full, either the full set or check, I want to sign these 3 rows. So it's still kind of the batch level, but it could be a much smaller subset of the full data that you're signing off on.
Yeah, but that kind of requires like an export. It's an export of those data.
Right. Yeah, it would not impact the the updated or modified by or created by attributes. That's right. And else was there another? Yes. For the QC states, there are not, at least not that I'm thinking of. You could certainly do some of the basic kind of charting, et cetera, to say what are the number of rows in the various conditions, not reviewed, approved, et cetera. But we don't have anything, kind of a pre-built dashboard that I'm familiar with that would summarize that. Yeah, I think something that could be very relevant for, say, sample management or manager, excuse me. LabKey people know we're trying to get our terminology aligned, and I'm behind the times. But I think that could be a very useful kind of dashboard status to have. Anyone else? Yeah.
Using schema metadata, is it possible to do QC states on other types of computer science assay runs?
Sure. So you could certainly, if you've got, say, a list and you want to track QC state on those, it would be easy to just have a field that's a lookup to that QC state table, which is effectively what's happening in data set. What wouldn't happen as a result of that is having a button automatically show up like we do for data sets to say update QC state. But maybe to your point, you could set the XML metadata on that query or on that table to wire up a button that works very similarly, because it's not a deep set of UI that happens on top of it. So you could simulate it pretty closely with that approach.
We can add metadata columns to some of these QC type data collections in the QC trends. Is there any way to visualize those non-standard metadata columns?
It's non-standard. So what type of?
I think we discussed a while back, but we were looking at corporate fleet instead of just a lab of instruments. So we could, in the assay build, okay, these are in Boston, these are in New Jersey.
Mm-hmm.
Parse them that way, we can get down to buildings and labs. But in the QC, is there any way that we can start pulling up those reports, pivoted around some of that metadata?
Right. So, and I know Gary is particularly interested in the mass spec side. So I'll maybe frame the response that way. So we haven't done anything directly to kind of maybe aggregate by those groupings. What we do have in Panorama, as I think you're already aware, is the ability to kind of a dashboard that looks at a bunch of different instruments that have their own QC folders and summarizes their data. Depending on what the folder structure looks like, we could certainly organize that based on location. So if we have a kind of basic QC folder, and then location 1, Massachusetts, location 2, Pennsylvania, as subfolders, and then maybe a separate folder underneath those for each of the labs in those locations, and then another one for the actual instrument. I think one of the most important things with this tracking is to make sure that if what you're doing is assessing the system suitability of a particular instrument, make sure we're only reporting on that instrument. That we're not in most of the views looking at a mix of data and trying to identify a trend in that, but certainly being able to roll up and say, no, we have many more outliers, on this one instrument versus this other instrument, and maybe it's the same instrument type, and there might be some insights to be gained from that. We don't have kind of a predefined dashboard for that, but I think based on kind of that folder structure, we might be able to get pretty close to that, and then work with you to create some interesting roll-up views on top of it.